Hello everyone, very good morning. I hope everyone is doing well. Yeah, Harshita, I'm good also. मैं भी अच्छी हूँ. So today in the class we are going to do questions from simple harmonic motions. ठीक है? So let's solve some questions. We will learn, important things that we need to apply in SHM. I have included mostly, PYQs, but that also old ones. New ones I have included a few. So basically, my target is to let you revise through how we can calculate time period in different cases and various other things. So let's start solving the questions. So let's start with this very simple and basic one. Yes. Okay. So let's read the question. Actually, this is very simple, I would say. This is just from the simple concept of how you can add two SHMs. ठीक है, vectorially. If you know how to do it vectorially, it gets very easy. So there are two simple harmonic motions. They are represented by y1 and y2. So if we look at y1, this is equal to 10 sine 3 pi t plus pi by 4. And if you talk about y2, then it is sum of two SHMs. One is your 5 sine pi t and another is your how much? 5 root 3 cos pi t. ठीक है? So we have all these three things. We have to calculate their amplitudes are in the ratio. Okay, so we have to calculate the amplitude of first one and amplitude of second one. So amplitude of first one you can clearly see it is 10, right? Because general equation of SHM looks like A sine omega t plus 5, where 5 the phase constant. It talks about what is the position of particle at initial time, I mean at t equal to 0. Okay, so for one it is a1 ka value it is 10. We need to calculate for a2. So देखो a2 is sum of two SHM. One is this, another is this. If you want to add it vectorially, make sure both SHM are of the same function. I mean one is in sine function, another is in cos function. So let's convert one into another. अगर मैं लिखूं यहाँ पे 5 sin pi by pi t plus 5 root 3 sin pi t plus pi by 2. ठीक है? Like that I can write. Okay. So I mean maybe negative sign में confusion हो यहाँ पे. I mean sin pi by 2 plus theta is how much? It is cos theta, right? Yes. Anyone? Sin pi by 2 plus theta को क्या लिखते हो?
cos
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 theta.
theta.
हाँ हाँ हाँ, डन है डन है। सो आई रिटन इट करेक्ट। अब आप देख लो यहाँ पे दोनों ही साइन फंक्शन में है। नाउ व्हाट यू हैव टू डू, सिंपली check the angle. So it has angle of pi t, and it has angle of pi t plus pi by 2. So let's say this is the line indicating angle pi t. So along the angle pi t, we have first SHM, which amplitude is pi. So this is a vector directed towards pi t, having length of vector equal to 5 units. If you consider second vector, then it is making an angle of pi t plus pi by 2. So this is already pi t, this line, plus pi by 2, you will go in the anti-clockwise sense. So here, and then this is this. So another one is this one, and this is 5 root 3. So you just need to add this two vectorially. अगर अब आप ऐड करोगे तो एम्पलीट्यूड y1 प्लस y2 का एम्पलीट्यूड कितना होगा बताओ? That you will write it 5 square plus 5 root 3 ka square. So if you do this, you will be getting 100, and that will give you 10. So initial first SHM has amplitude of 10. Second also has amplitude of 10. We can say ratio is 1. ठीक है? अगर मुझे तीनों ही SHM, अगर कहता कि y1 प्लस y2 का तुम रेशियो बताओ, सॉरी y1 प्लस y2 का एम्पलीट्यूड बताओ, देन व्हाट यू विल डू, आई मीन y1 कैसे जोड़ते फिर यहाँ पे देखो, जोड़ सकते थे क्या वेक्टोरियली? यस, क्योंकि यहाँ पे भी 3 पाई टी है, सॉरी मैंने 3 नहीं लिखा है, दिस इज ऑल आर हैविंग सेम एंगुलर फ्रीक्वेंसी राइट। सो अगर ऑल थ्री को ऐड करना है ना, तो सिंपल यहाँ पे ऐसे लाइन बनाओ, 3 पाई टी का लाइन है ये बेसिकली। सो लेट्स कीप एवरीथिंग इन साइन। सो दिस इज 3 पाई टी प्लस 5 by 4. So one vector is at an angle of 45 degree, and how much is its amplitude? 10. This is 5, and then there was one at 90 degree. That is how much? That is 5 root 3. So we simply needed to add all these three to get the amplitude of y1 plus y2. ठीक है? यहाँ पे मैंने opposite लिख दिया है क्या? हाँ. This is amplitude of y2, right? Sorry. So this way you can calculate it easily. Vectorially we can go and do things more, or make things more easier. Now let's do this question. ठीक है? Okay, anyone got anything? Okay, I got one correct answer. That's great. ठीक है. Chalo, let's end the poll and let's discuss it. What is the question given? There is a uniform cylinder. Length is L, mass is M, and it is submerged in liquid. Not completely, half of it is submerged. And when half of it is there inside water, it is in equilibrium basically. And from equilibrium position, if we are disturbing it a bit downward, I mean, we are pulling it downward by a small distance, then what is happening? It is performing SHM. Then we have to calculate frequency of oscillation of the cylinder. I mean, how we can calculate frequency of oscillation just by writing the equation of SHM. How we can reach up to the equation of SHM? There are two ways, either by using energy conservation thing or by using force thing. ठीक है. सो एनर्जी कंजर्वेशन हम क्यों यूज कर सकते हैं? क्योंकि जब भी एसएचएम हो रहा है ना, इफ मोशन इज पीरियोडिक, इट हैज अ मीनिंग दैट इट इज नॉट डैम्प. I mean, if amplitude is constant, things are there like this. It means energy is not changing. It is remaining constant. Done it? So, कोई भी time t पे, general time पर, you can write the equation of energy. Total energy you can write. You can make it constant, differentiate it, you can get it. We will do it later in questions coming ahead. And in some cases, we simply need to write the force. अब तुम्हें कौन से केस से जाना है will depend on कि which is more easier where. In this case, we will go with the force because it's more easier here to write the force acting on it. So if you talk about equilibrium position, how it will be in equilibrium? Simple hai. It has a okay with this. Okay, so what is there? There is a massless spring here, right? There is a spring here. So when it is in equilibrium, what will happen? Mg force will act downward. Center of gravity will be somewhere here because whole volume is not inside water. Sorry, not center of gravity, center through which force of buoyancy will act. It won't be through the middle point of the cylinder because you can see here, whole volume of the body is not submerged inside. So let's say from here, again, force of buoyancy will act and it will act in the opposite direction. I mean, force of buoyancy is what? It is the equal to the weight of liquid displaced and it acts in the vertically upward sense. Okay. So this value will be equal to how much? Let's for now write it. It will be how much? Batao. Volume of cylinder ka half into density of liquid into G. This is going to be the force of buoyancy. And this is attached with a spring. So spring force will be upward because tension always acts away from the body. Spring force, again tension force. So Kx, sort of tension force, right? So Kx, अगर इस body का FBD diagram अब आप देखो, it looks like in the upward direction, force of buoyancy plus force of a spring, and in downward direction, we have force of gravity. So if it is in rest, we need to equate these two. पहले आप इसको equate कर लो. So when you will equate these two, what you are going to get? You will get Kx naught, where x naught is what? X naught is the extension in the spring when system is in equilibrium. So let's write it x naught. So Kx naught plus V by 2 rho Lg will be equal to V rho G. M into G. Rho I have taken as density of the mass of cylinder. So this is the case in equilibrium position. Now what we are doing is we are shifting the cylinder a bit downward. अगर आपने इस cylinder को थोड़ा सा नीचे लेकर अगर आप आते हो, then what will happen? A spring will get extended by further some more distance. Let's say by delta x. So by delta x. ठीक है? So let me draw the diagram again. This is the cylinder. And when you are disturbing it from equilibrium position by distance x naught, sorry, by distance delta x, then extension in a spring will become how much? Delta x naught, sorry, delta x plus x naught, because x naught was extension in the equilibrium case. And now how much of liquid or how much volume of the cylinder will be inside water? Initially up to this, since you are pulling it down, more volume will come inside. ठीक है? So let's say up to this volume, it is inside the liquid. So what will be the extra volume that you are adding in here? This will be equal to this, and this height is equal to delta x. This is area of cross section A. So this is basically A delta x. Done it? सो इट इज लाइक दिस वी कैन डू. अब यहाँ से देखो और क्या फोर्सेस लगेंगे इस पे. Let's now talk about the forces. So mg will remain same as before. So this is v rho g. What will be the value of tension force? That is your k delta x plus x naught. What will be the value of force of buoyancy? So force of buoyancy acting in the upward direction. Value will be how much? It will be v. How much is the volume? So volume is v by 2 plus a delta x. This is the volume into rho L into g. This is going to be the new force of buoyancy, right? Now, if you are displacing it in the downward direction, if it is performing SHM, net force will act in this sense. So basically, upward force is greater than downward force. So let's subtract it. अब क्या करोगे आप? सिंपल है, एफ नेट आप लिख दो, क्योंकि हियर नेट फोर्स इज नॉट जीरो. इट इज नॉट द इक्विलिब्रियम केस. वी हैव डिस्टर्ब्ड इट फ्रॉम द इक्विलिब्रियम. अब आप एफ नेट को लिख डालो. अगर आप एफ नेट यहाँ पे लिखते हो, व्हाट यू विल राइट, अपवर्ड फोर्स को ऐड करो, रो जी वी बाई टू प्लस a delta x. This is the force of buoyancy plus k x plus x naught. Sorry, x plus x naught plus delta x minus v rho g. This is the net force acting, right? इसको अगर आप ब्रेक करोगे, you can clearly see here rho z v by 2 plus rho g a delta x plus if you write here, this is k x naught plus k delta x minus. चलो एक काम करती हूँ, मैं बहुत ज्यादा क्रैम्प्ड लिख रही हूँ. शुड लुक क्लियर, राइट? लेट मी राइट इट फास्ट. सो रो जी v by 2 plus रो g a delta x plus k x naught plus k delta x minus v रो g. अब आप देखो कौन किससे कैंसिल हो जाएगा. इफ यू लुक हियर केयरफुली, इक्विलिब्रियम सिचुएशन पे जाओ. v रो g किसके बराबर है? k x naught plus v by 2 रो l g. यहाँ पे आप ध्यान से देखो, v by 2 रो l है दिस वन, and this is also rho L. So rho L g v by 2 plus kx naught. This term and this term will get cancelled by this term, right? So इसको हटा दो. How much value you are going to get? Rho L g a delta x plus k delta x. So how much value you are going to get? Rho L g a plus k delta x. अब तुम कहोगे मैम इतना लिखना जरूरी था क्या? अगर मैं डायरेक्टली लिखती ना, मैंने तुम लोगों के लिए इतना लिख दिया, बट अगर मैं डायरेक्टली लिखती तो मुझे डायरेक्टली दिख रहा है कि एक्स्ट्रा फोर्सेस क्या आए. जस्ट फोकस ऑन द एक्स्ट्रा फोर्सेस. देखो यहाँ पे कितना एक्स्ट्रा फोर्सेस आया, के डेल्टा एक्स. हियर हाउ मच एक्स्ट्रा फोर्सेस? रो एल जी ए डेल्टा एक्स. सो के डेल्टा एक्स एंड हाउ मच, के डेल्टा एक्स प्लस रो एल जी a delta x. This is the extra force you are getting. Sorry. सिंपल है. तुम्हें एसएचएम में इतना, अगर तुम्हें क्वेश्चन ये रहता है कि प्रूव करो एसएचएम है कि नहीं, पता करना है, देन यू नीड टू राइट एवरीथिंग प्रॉपरली विद द साइन. बट इफ इट इज ऑलरेडी गिवन, ऐसे भी अगर नहीं भी गिवन है, यू कैन, यू नीड टू चेक. देखो यहाँ पे v रो जी क्या रह रहा है? कांस्टेंट रह रहा है. सो डाउनवर्ड फोर्स इज कांस्टेंट. व्हाट इज हैपनिंग विद द अपवर्ड फोर्स? दिस इज डिक्रीजिंग as we are displacing cylinder downward by distance delta x. So there will be a case of, there may be a case of SHM. If it is yes or not, then you need to write the extra forces. Extra force क्या क्या है? देखो k delta x plus rho l g a delta x. This is the extra force. So extra force, that is F net, is equal to k plus rho l g a delta x. So you can see clearly here, F is directly proportional to delta x, and you already know this is acting in the upward direction. Delta x is in the downward direction. So if direction wise अगर आप check करो, then this is like this. So there is a case of SHM, and this thing is your omega square, k plus rho L G A. So इतना लिखने की जरूरत नहीं थी. You just need to check with the extra forces acting. Done है? So यहाँ पे आप ओमेगा स्क्वायर को क्या लिखोगे? k plus a. यहाँ पे डेंसिटी ऑफ लिक्विड इज गिवन एज रो. सो ए रो जी, यही आया था ना हमारा, a plus rho g a. Yes. So this is your omega square. Omega will be root under k plus a rho g. We needed to calculate what? फ्रीक्वेंसी, राइट? यस। सो टी इक्वल टू क्या होता है, 2 पाई बाई ओमेगा, सो दिस इज इक्वल टू 2 पाई बाई, ओके, हैव आई मिस्ड ऑन समथिंग, मास इज मिसिंग आई गेस।
Yes,
अच्छा,
ma'am.
एफ नेट लिखा है ना मैंने, हाँ सॉरी सॉरी। सो दिस इज मास इनटू एक्सेलरेशन बेसिकली। तो एक्सेलरेशन को लिखोगे ना यहाँ पे, देन यू विल मेक दैट ओमेगा स्क्वायर। सो ए इज इक्वल टू दिस डिवाइडेड बाय मास, राइट? तो यहाँ पे दिस डिवाइडेड बाय मास होगा, दिस डिवाइडेड बाय एम। अकॉर्डिंगली नाउ यू कैन राइट फ्रीक्वेंसी। सो दिस इज हाउ वी सॉल्व इट, फोर्स ऐसे हम लिख सकते हैं इजीली। डन है, आई होप यू हैव अंडरस्टूड। लेट्स डू मोर नंबर ऑफ क्वेश्चन टू गेट मोर accustomed with this thing. So do this question. Read it, right? ठीक है? Okay, I got two answers, one correct, one wrong. देखो इस क्वेश्चन को, आई मीन इफ यू नो इट, यू विल डू इट क्विकली। व्हाट्स योर नेम फर्स्ट? सम प्रो मैथ्स, क्या है ये? ओके, द ऑप्शन इज नॉट करेक्ट एक्चुअली। देखो, दिस इज अ क्वेश्चन ऑफ सिंपल पेंडुलम। सिंपल पेंडुलम का सिंपलेस्ट केस में व्हाट इज द टाइम पीरियड? हियर टाइम पीरियड वी आर आस्क्ड, राइट? सो टाइम पीरियड का सिंपल फॉर्मूला क्या होता है? 2 पाई रूट अंडर एल बाई जी, एंड दिस जी इज बेसिकली जी इफेक्टिव। ऑलवेज रिमेंबर दिस इज जी इफेक्टिव। सपोज कर लो तुमसे किसी ने बोला कि देर इज अ पेंडुलम एंड यू आर, अभिजय, इतना प्यारा नाम है, तुमने ये क्यों रखा है? ओके, थैंक यू लेट फॉर लेटिंग मी नो। चलो, सो यहाँ पे जी इफेक्टिव निकालना है। लेट्स से यू आर आस्क्ड, यू आर एट सर्टेन हाइट फ्रॉम द surface of earth, what will be the time period of the pendulum? So there you will calculate g effective. डन है? g जैसे निकालते हो वैसे निकालोगे आप। डन है? but this is the simplest. अगर आप सोचते हो, अगर ऐसा दिया रहा, लिफ्ट है, लिफ्ट के अंदर पेंडुलम रखा हुआ है, सपोज कर लो लिफ्ट इज गोइंग अप विथ एक्सेलरेशन ए, व्हाट विल बी द टाइम पीरियड ऑफ सिंपल पेंडुलम? हाउ वी गो अराउंड इट इन दिस क्वेश्चन? कैसे करेंगे बताओ? सो सिंपल है, जी इफेक्टिव निकालना है। और जी इफेक्टिव हम कैसे निकालेंगे? नट सेल में तुम्हें इक्विलिब्रियम पोजीशन पे इक्वेशन लिखना है। ठीक है? कहाँ लिखना है? इक्विलिब्रियम पोजीशन पे। So in equilibrium position, tension of the string will get equated by something. So let's write here, जैसे अगर सिंपल अर्थ पे रखा हुआ है तो तुम बोलोगे T इज इक्वल टू एम जी। सो T इक्वल टू क्या लिख रहे हो? एम जी। यहाँ पे M के बाद जो भी टर्म है दैट इज योर G इफेक्टिव। ठीक है? सो बेसिकली यू हैव टू इक्वेट T विथ समथिंग। डन है? यहाँ पे चलो तुम इक्विलिब्रियम का केस लिखो। सो इफ यू राइट हियर T इज दिस, एम जी इज दिस, एंड सिंस दिस इज एन एक्सेलरेटेड सिस्टम, यहाँ पे कह सकते हो कि T माइनस एम जी इज इक्वल टू एम ए। सो टी किसके बराबर आ रहा है? एम जी प्लस ए। तो हियर जी इफेक्टिव इज व्हाट? जी प्लस ए। ठीक है? इफ लिफ्ट इज गोइंग डाउन विथ एक्सेलरेशन ए, जी इफेक्टिव विल बिकम जी माइनस ए। Now let's say there is a car, and on in this car there is a pendulum. Car is accelerating in this direction A. ठीक है? Now if you go on to write the equilibrium situation of this pendulum, let's say I'm sitting here and then I'm going to write the equation. So at first I will write pseudo force Ma, and then there is tension T, then there is Mg. Remember, always you have to equate tension with something. So Ma and Mg ka force idhar jayega. Done it? And because of this resultant force of Ma and Mg, string will get shifted like this, such that tension T will get equated with this force. So T equal to यहाँ पे क्या जाएगा? M root under a square plus g square. So in this case, what is the g effective? G effective is this one. Okay. In our question, what is the case? There is one inclined plane, and then there is this car system. There is a pendulum here. I mean, this won't be the real situation of pendulum, but let's draw it like this first. And this car is coming down with which moves without friction down an inclined plane. If something is moving without friction down an inclined plane and inclination is given an alpha, then this will become how much? G sine alpha. Its acceleration will be what? Down the plane. G sine alpha, right? So if I sit here and again write the equation, what I will be writing for this thing? क्या लिखूंगी बताओ? See, I will do one thing. I will simply हमारा पेंडुलम ऐसा है, ठीक है? पेंडुलम ऐसा है, and this is tension T. This is I mean force acting on the pendulum mg, and then this since we are sitting in which frame? We are sitting in non-inertial frame. From non-inertial frame, I am going to write the equation. So I will write one force, that is pseudo force, like this. So this is mg sine alpha. This is mg sine alpha. So definitely this pendulum won't hang like this. It will get shifted in the direction of net force of mg and mg sine alpha, right? समझ रहे हो? So that will be somewhere here, and so pendulum will get shifted like this. So कुछ ऐसा रहेगा pendulum ऐसा, ठीक है? Now we need to calculate equivalent of mg and mg sine alpha. What is the angle between these two forces? अगर आप इस एंगल की बात करो तो देखो ये था mg and this was your mg sine alpha. What is this angle? अगर इस एंगल की आप बात करो, this angle is alpha, right? And this is 90 degrees. So overall angle is 90 plus alpha. This is how much? 90 plus alpha. इन दोनों का force आप निकाल लो. If you will calculate it, you will write mg का स्क्वायर प्लस mg साइन अल्फा का स्क्वायर प्लस 2mg into mg sine alpha into how much? Cos 90 plus alpha. This is going to be the net force, right? If you write it, you will get m square g square plus m square g square sine square alpha. And this cos 90 plus alpha is how much? Cos 90 plus alpha will become second quadrant, it will become negative. So minus sine alpha, and this will become 2m square g square sine square alpha. ठीक है? Root under this. This will become how much? M square g square minus m square g square sine square alpha. If you solve it, you will get how much? Mg root under 1 minus sine square alpha, that is cos square alpha. So this is basically mg cos alpha. अब आप देखो टेंशन किससे इक्वेट होगा? यहाँ पे टेंशन इक्वेट होगा mg cos alpha से in a particular inclination, in a particular position like this. This is equilibrium position. So T equal to what? M into something, that is g cos alpha. So here g effective is this. ठीक है? So you will write here answer will be your A. 2 pi root under L by g cos alpha. That is how we solve such question. So जब भी तुम्हें simple pendulum का question हो and system is not simple, which won't be in JEE advanced exam, then and if you are asked to calculate time period, go with writing tension is equal to something net force. ठीक है? Then M into whatever you are getting, that is G effect. That way you will deal with the question. Now let's do this question. ठीक है? Think around it, do it. Let me. Okay, I got one answer, but that doesn't feel correct. Okay, two answers, one correct, one incorrect. Let us discuss it. देखो क्वेश्चन क्या है? क्वेश्चन है we have two blocks like this. There is one is resting on a frictionless surface, I guess. Yes, Abhijay, that's correct. ठीक है. So basically two mass system है and there is a spring directly connected to the Q. To P it's not connected, but it is said in the question. I mean this is frictionless surface, right? Yes. Here friction is zero and here there is friction coefficient and it is performing SHM such that there is no slipping between these two things. कोई slipping नहीं है. So how to deal with this question? ध्यान से देखो, if both are performing SHM and there is no slipping, इसके बीच में relative motion नहीं है. इसका मतलब with whatever velocity or acceleration Q will move, with same velocity and acceleration P will move. Because there is no relative motion between P and Q. There is no slipping. No slipping का मतलब no relative velocity, no relative acceleration, no relative displacement. That is no slipping case. What does it mean? Let's talk about any random position where a spring, I mean where the displacement of this two mass system is x. Let's say this is the situation. ठीक है? यहाँ हमने P को रखा and then here is Q. Let's say we are here, we have moved here by distance x. So if you talk about acceleration, when displacement is x, then acceleration you will be writing as what? A you will be writing as, I mean whatever you write, mine A को A ही रहने दो अभी. Free body diagram लिखने की कोशिश करो. So if you write the free body diagram of Q, then since this is a stretched spring, Kx will act in this direction. And is there any other force acting? Yes, there is friction coefficient between Q and P. So friction will operate between Q and P because Q has tendency to move on the surface of P, right? So friction will act here. And what will be the value of friction here? We don't know. So let's say friction acting on the surface Q is in which direction? Is in this direction. Because external force on body Q is Kx in the left hand side, then friction will operate on the right hand side. So then I will write acceleration which is directed towards this direction, Kx minus A equal to Ma. I can write, okay? Free body diagram of Q I have written like this. Now if you talk about P, क्योंकि P, there is no relative motion between P and Q. So P is also moving with the same acceleration. अब आप एक काम करो, P का FBD बनाओ. So P का बनाओगे, P is not directly connected with the spring. Sorry, यहाँ पे मैंने direct connect किया है. P is not directly connected with the spring, so no spring force. Only reaction of this spring force will come to the surface of P. So there is F. And there is only one horizontal force acting F and this should be equal to Ma. Done है. अब इन दोनों इक्वेशन को अगर आप सॉल्व करोगे, then what you will get here, I mean F की जगह आप M रखो या फिर हमें निकालना क्या है? हमें निकालना है फ्रिक्शन. तो Ma की जगह आप फ्रिक्शन रखो in equation 1, then you will get what? Kx is equal to 2f and F is equal to Kx by 2. What will be the maximum value of friction? Will be for the maximum value of x, that is A. So maximum value of friction will be how much? Ka by 2. This is how we can solve it. ठीक है, क्योंकि यहाँ पे टोटल सिस्टम है तुम्हारा P plus Q. Done है, and both are together performing SHM of amplitude A. Done है. It is asked what is the maximum value of friction operating between P and Q. For that you need to enter into system and write the free body diagram of P and Q separately. taking their acceleration same, then you will get this case. ठीक है, यहाँ पे देखो सी ऑप्शन ऐसे ही कट हो जाएगा, बिकॉज दिस इज आई मीन मैक्सिमम फ्रिक्शन फोर्स, we cannot say like this, जीरो तो लग नहीं रहा, ठीक है. So we simply need to solve it and see what is the case. ठीक है, चलो, option was A. We got A, right? Yes. Now let's do this question. Here you don't need to think much. You just need to be clear of the basic concepts. So question को ध्यान से पढ़ना, I would say. Done it? If not, let me discuss this. ठीक है, क्वेश्चन क्या है देखो. तुम लोग फर्स्ट क्वेश्चन को, सेकंड क्वेश्चन को याद करो, वेयर आई सेड इफ यू हैव टू कैलकुलेट द नेट फोर्स, सिंपली चेक द फोर्स, द एक्स्ट्रा फोर्स दैट वी गॉट और द फोर्स दैट चेंज्ड. ठीक है, हमने वही किया था ना. यहाँ मेरे कहने का मतलब ये है, व्हेनेवर यू आर डीलिंग विथ एसएचएम, ठीक है, हाउ आई मीन फ्रीक्वेंसी एंड थिंग्स विल गेट अफेक्टेड व्हेन. जैसे, okay, let me first deal with the question, then you will understand it more. There is a wooden block perform SHM on a frictionless surface with a frequency V naught. The block carries a charge plus Q on its surface, and okay, so initially when there is no electric field, frequency is given of the system of this SHM, that is V naught. Okay, now what is happening? We are switching on the electric field. Okay, as shown in the figure, then SHM of the block will be what? Frequency change करेगा, क्या होगा? So let's talk about the moment we switch on electric field on this plus Q charge, which is resting on the body. So you can say there is a body of plus Q charge. When you will switch on electric field in this direction, what will happen? On this charge, force will act in this direction, in the direction of electric field. It is attached to the spring. It will get compressed by certain distance. So it will lie on this surface, compressed like this. Okay? So at compressed position, what will happen? QE will be equal to KX naught at equilibrium position. Okay? So X naught will be equal to QE by K. Initially, when there was no electric field, X naught was what? It was zero, because initially when you're not displacing it by any distance or you're not giving outer impulse, it will remain like this with extension in a spring, zero. Okay? But since you switched on the electric field, you supplied a force, and because of that force, its equilibrium position is going to change. Initially, equilibrium position was what? X equal to 0. Finally, equilibrium position is what? X naught is equal to QE by K. And now from this equilibrium position, if you are going to shift this mass either to this direction or to this direction by small displacement delta X, it will perform SHM. And in this SHM, there is going to be no other difference than the change in equilibrium position. यानी कि ये भी simple एक spring block system का SHM है, where omega will be equal to root under K by M. No difference is going to come. ठीक है? Because when you are displacing the mass, I mean from equilibrium position, when you are disturbing the mass, is electric force changing? No. That is a constant thing. So whatever is constant thing will have no role in omega. ठीक है, जैसे प्रीवियस केस में मैंने ग्रेविटेशनल फोर्स को कांस्टेंट, वो कांस्टेंट था जो हम ये सिचुएशन, दिस क्वेश्चन वी डिड राइट. सो हियर वी mg वाज कांस्टेंट, इसलिए जब मैंने चेंज इन फोर्स लिखा था ना, आई डिडंट राइट mg. I simply wrote the force that will change with cylinder getting disturbed from its equilibrium position, and that will determine the value of omega. So omega will basically depend on what? On the force that whose value is changing with the small or big displacement, right? And here there is only one such force, that is kx, and that is why only extra force में क्या आएगा तुम्हारा? Minus kx. And so ma is equal to minus k, a equal to minus k by mx, and hence omega square is k by m, and hence omega same, right? So correct, sorry, not this question, it was this question, right? So question क्या, answer क्या होगा? Of the same frequency and with the shifted mean position? Yes. Of the same frequency and with the same mean position? No. It is no, 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 right? So we can write it like this. Okay. Chalo, now again, let's do some sort of question. This is also some PYQ. I don't remember which year, but yeah. Do it and let me know. If you do it vectorially, you will be able to do this within 1 minute. You just need to look at things carefully. No. Be more mindful. I mean, check it. Vectors को draw करो, you will get the idea instantly. Yes. Okay, you should have done it by now. Let's check. What is this? There is a point mass. This is subjected to two simultaneous sinusoidal displacements in x direction. One is this, another is this. And we have to add a third sinusoidal displacement to bring the mass to a complete rest. Yani ki we have to get x1 vector plus x2 vector plus x3 vector equal to 0. We have to make it null vector overall, right? So मैंने बोला यहाँ पे देखो, साइन के अंदर एंगल क्या है? ओमेगा टी. टाइम से जो भी वेरी कर रहा है, दैट एंगल यू लुक एट. हियर आल्सो दिस इज ओमेगा टी, हियर आल्सो दिस इज ओमेगा टी. So let's take a line of omega t. Let's say this is the line of omega t. In this direction, we have one vector of amplitude a, of length a, let's say. Another vector is in which sense? Omega t से कितना एंगल बना रहा है? Plus 2 pi by 3. That is 120. So another is in this direction. And this value is how much? A. And this angle is how much? 120. We have to add third vector such that to get whole as a 0. How we will get it? तुम लोगों ने एक चीज पढ़ा होगा. If we have three vectors at 120 degree, three equal vectors at 120 degree, resultant is 0. क्योंकि ऐसे भी तुम देखो, a और a का रिजल्टेंट क्या होगा? It will go from the middle, right? So x1 plus x2, if you talk about, this is along this direction, making an angle 60 degree with omega t. Why? Because both vectors are equal. So its resultant will make equal angle with both individual vectors. Now third you need to add here. And its magnitude should be the equal to the magnitude of x1 plus x2. A और A को आप ऐड करो at 120 degree, you will get A itself. A square plus A square plus 2AA cos 120. This is equal to 2A square minus A square, because cos 120 is minus half, so this is A. Done it? So its resultant is A. It means here also it should be A. And how much angle it will make? Angle measurement you will do in which direction? We have to add with omega t. If you have to add, then you will go in the anti-clockwise direction. So this angle. How much is this angle? Up to this is 120 and this is 120. So 240. And 240 meaning how much? 4 into pi by 3. That is 16 to 4, right? So correct answer should be what? Batao. Correct answer should be what? Which option you feel? Correct option should be D, right? So vectorially you can make it very easy. You can do it. I mean instantly. Okay? So keep this thing in mind. This is actually very helpful when we are dealing with SHM. In SHM, you have to use this vector method whenever you have to talk about the net amplitude or something. So please have this in your mind. Okay, now let's do this question. This came in mains, but I really feel like we should discuss this. So let's do it. I will also show you the variation of questions that we will be getting here. Okay. Take your time, do it, let me know. Okay, I hope you all must have drawn the question. For a minute, I will be stopping the share. Just give me some second. Done it? Everybody take your time, do it. Okay, Harshvardhan. Yes, it feels correct. Yeah, it is actually. Great. Okay. Okay, let's do it now. Let's do it together. Okay? Okay, you solved it by using TOG. ठीक है? Force या TOG use कर सकते हो. Here I will show you the application of energy वाला concept. ठीक है? So that you can use that also whenever you get confused with the force thing. And basically that energy concept is more helpful when you have to deal with rolling cases and their SHM is asked. Okay? So I need to discuss this here with the simplest one first. So see this case. Suppose this is the position where rod is in rest. What I am doing now, I am simply rotating this rod or this, क्योंकि for SHM to happen, we first displace things from its equilibrium position. I am displacing this rod by an angle delta theta. So if you will displace this rod by an angle delta theta, what will happen? Rod ka this position will go this side, so it will compress the spring first, and this position will go somewhere more this side, right? So both the springs will get compressed. Okay. So when you displace this rod by an angle delta theta, rod will have certain angular velocity. Both spring will be in compression. So how many energies you are going to get? Two potential energies. That is potential energy of this rod and sorry, this spring and potential energy, sorry, kinetic energy of this rod. Okay. So let's say in a spring one there is a compression x1. So half k x1 ka square plus half k x2 ka square in the bottom string plus half I omega square. This will remain always constant. This is going to be fixed always. Because this system is performing SHM, there is no dissipative force acting. So this is constant. Now you just see here, there is one rotational kinetic energy term. Here there is omega thing. ठीक है. So एक काम करते हैं, पहले पहले तुम्हें क्या होता है, टोटल एनर्जी लिखना होता है. आफ्टर दैट यू नीड टू डिफरेंशिएट इट विथ रिस्पेक्ट टू टाइम. सो लेट्स फर्स्ट डिफरेंशिएट इट. If I differentiate it with respect to time, I will get half k into 2x1 v1. ठीक है, क्योंकि x1 स्क्वायर को डिफरेंशिएट करोगे विथ रिस्पेक्ट टू टाइम, you will get 2x1 into dx1 by dt. That will give you v1. Similarly, here you will get half k 2x2 v2 plus half I 2 omega alpha. Why alpha I am writing? Because omega square को differentiate करोगे time के respect में 2 omega d omega by dt, that is alpha I have written. ठीक है, and this is equal to 0 because constant का differentiation is 0. Now if you solve it, this will become how much? K x1 v1, this is how much? K x2 v2 plus how much? This is 2 यहाँ भी cancel होगा, I omega alpha. This is equal to 0. But there is one problem here. Problem is velocity और omega का term है. Either you convert v into terms of omega or something, or omega into v का term. So let's do one thing. Let's convert v1 to I mean v1 in terms of omega and length. ठीक है. How we can do this? We can do it very easily here. जैसे देखो v1 किसका velocity है? Point A का. Point A का ही velocity है ना v1, because I mean the x1 is what? X1 is the displacement of this position, and how by whatever distance this A will get displaced, by the same distance the spring will get compressed. So basically x1 is displacement of A position, v1 is velocity of A point, and what will be the velocity of A if its angular velocity is omega? This is at a distance of L by 2 from here. So this is omega L by 2. अब आप यहाँ पे simply लिख दो k into omega L by 2 into x1 को क्या लिख सकते हैं? अगेन x1 को भी हम लोग थीटा के टर्म में लिख सकते हैं. I have displaced it by an angle delta theta. So x1 can be equal to what? R delta theta. R is how much? L by 2. So again L by 2, how much? डेल्टा थीटा. सो मैंने v1 को क्या लिखा? मैंने v1 को लिखा ओमेगा आर, आर इज एल बाई टू, एंड मैंने x1 को लिखा आर डी थीटा, आर इज एल बाई टू डेल्टा थीटा. सिमिलरली यहाँ पे आप लिखोगे k x2 क्या हो जाएगा तुम्हारा? अगेन दिस इज ऑल्सो एट अ डिस्टेंस l बाई टू, सो v1 and v2 are going to be the same. So k omega l by 2 into l by 2 delta theta, and this is equal to minus I ओमेगा अल्फा. देखो यहाँ पे मैंने ओमेगा का टर्म लिखा है ना? हाँ लिखा है. अब आप इसको सॉल्व कर दो. यू विल इट विल गेट सॉल्व. से ओमेगा कैंसिल हो गया, और यहाँ पे अगर आप ध्यान से देखते हो एल बाई टू इंटू एल बाई टू, के एल स्क्वायर बाई फोर, एंड दिस इज ऑल्सो के एल स्क्वायर बाई फोर. सो बेसिकली के एल स्क्वायर बाई टू is equal to into delta theta is equal to minus I alpha. Now you put the value of I, you will get the answer. ठीक है. So यहाँ पे मैं क्या लिखूंगी? Maybe it might be feeling lengthy as of now, but if you have clarity of this concept, you can use it easily. Here the confusion is less because You know what is the energy. You simply need to differentiate it after that. Somewhere force writing becomes difficult in case of rolling and all. Here you can write it easily. So KL square by how much we got it? KL square by 2 delta theta. By 2 delta theta equal to I कितना होगा? ML square by 12 into alpha. ठीक है? With negative sign. So from here you can solve it. L square will get cancelled. So delta theta, this is 6k by m delta theta equal to alpha with negative sign. So this is omega square. Omega square is 6k by m. You can also apply torque and you can write it. Torque के केस में क्या करते तुम? Torque के केस में सिंपल था. यहाँ पे फोर्स लगा. यहाँ पे because if you are displacing it by an angle delta theta, it will get displaced by certain angle and hence force will act here kx1. Here also force will act kx2. x1 and x2 will be same. And then you can calculate torque of this around the center of mass of this thing, and you can write net torque equal to I alpha, and you can solve it. ठीक है? So you can do both ways. इस क्वेश्चन का वेरिएशन और भी हो सकता है कि लेट्स से देयर वाज दिस स्प्रिंग. A spring is not connected to the top end, rather to this end or to this end at different distances. ठीक है? Then you have to be careful with this distance. ठीक है? Properly you will convert things. Then, so correct answer should be what? Yeah, this one. Let's do more questions. Yeah, this is the easiest one. क्योंकि अभी तक मैंने ऐसे क्वेश्चन को बहुत ज्यादा इंक्लूड किया है. Just to make things more clear. So do it fast within 1 minute. After that, we will go with the other type of questions. So this is multiple choice. So you need to send me more than one correct answer. Yes. Anyone? Okay, let's do it. X equal to how much? A sine square omega t plus B cos square omega t plus C sine omega t cos omega t. We have to talk about this represents SHM. So SHM का जब भी इक्वेशन लिखते हो ना, try to write it in single power of sine or cos. ठीक है? हर्षवर्धन. Yes, that one is correct. Yeah. So try to write it in single power of साइन और कॉस. सो इसको आप चेंज कर दो. ए साइन स्क्वायर ओमेगा टी को आप क्या लिख सकते हो? 1 माइनस कॉस 2 ओमेगा टी बाई 2. इसको क्या लिख सकते हो? 1 प्लस कॉस 2 ओमेगा टी बाई 2. इसको क्या लिख सकते हैं? सी दिस विल बिकम साइन 2 ओमेगा टी बाई 2. ठीक है? सो दिस इज बिकमिंग हाउ मच? दिस इज बिकमिंग a by 2 plus b by 2. So a plus b by 2 plus this will become how much? B minus a by 2 cos 2 omega t plus c by 2 sin 2 omega t. This is the equation of SHM. Constant term has no significance other than telling you what will be the mean situation or something. ठीक है? सो कांस्टेंट का एम्पलीट्यूड से कोई लेना देना नहीं होता है इक्वेशन में. व्हेनेवर यू गेट x इक्वल टू समथिंग एंड देयर इज अ कांस्टेंट टर्म व्हिच इज नॉट चेंजिंग विद टाइम, इट वोंट कंट्रीब्यूट टू द एम्पलीट्यूड. ठीक है? Now let's go to the option A for any value of A, B, and C. This represents SHM for any value of A, B, and C. For X to be SHM, there should be term of sine or cos. Okay? If we take A is equal to B, this term will become 0. And if we keep C equal to 0, then this will also become 0. And X will become A plus B by 2, which is not an equation of SHM. So option A will be wrong. Okay? Now let's check if A equal to minus B. So if A equal to minus B, in that case, what will happen to this thing? A को minus B लिखते हो 2B by 2. So this will become B cos 2 omega t. And C equal to 2B अगर आप लिखते हो, this will become B sin 2 omega t. ठीक है? So these two are two different SHMs with phase difference of 90 degree. So one is B, another is B with phase difference of 90 degree. Resultant will be how much? Resultant amplitude root 2B. So this seems correct answer B. ठीक है? If A equal to B, अगर हमने A equal to B कर दिया और C equal to 0, so this won't remain SHM. We have already checked it. So this is wrong. If A equal to B, ये 0 हुआ, C equal to 2B, amplitude will be B. क्योंकि in that case, this is not representing at all SHM branch. If A is equal to B, this will become 0 and this will only remain B sin 2 omega t, which is an equation of SHM with amplitude B. So correct option should be B and D. ठीक है? I hope now you're clear about in any term, in any equation of SHM, if you're getting constant term, how to go around it, how to deal with it. ठीक है? Now let's do this question. Everyone read it carefully and let me know. ठीक है? I'm here only. Sorry, I was muted. I was speaking. So what I'm telling is, yes, it is multi-option correct thing, and that you can read from the question also. There is which of the following statements is correct. So yes, multiple choice. Any clue? Any idea? 。 Yes. So we do it together. चलो एक काम करते हैं, डिस्कस करते हैं क्वेश्चन को, हाउ वी कैन डील विथ मोमेंटम इन सच केसेस. Yes, Harshvardhan, both are correct. But both are correct. One more option is correct. ठीक है? Great. So let's do this question. Let's understand it first. So there is a block of mass m here, and that is connected with the massless spring of a spring constant k that is given in the question. And block's equilibrium position is x equal to x naught. It is performing SHM with amplitude a. Okay, and what we are asked in this case, what is happening? We are dropping one mass, right? When the block is at x naught and when the block is at x equal to x naught plus a, in both cases, a particle with mass small m, which is less than capital M, is softly placed on the block. Softly placed, matlab, I mean, we are not giving any additional or external force. Softly, we are keeping it there such that they stick to each other. They stick to each other means they will move as a system. Read every point carefully. They will stick to each other. Means together they will form a system. So they will perform SHM together. Okay? So finally, when you are dropping the mass, SHM will become, or SHM will look like there is a spring connected with mass n plus small m. It will look like this. But the difference is in one case, we are dropping the mass when this capital M mass is at x naught and another time when it is at extreme position. What differences will occur? So the very common difference that you can spot just by looking at position, that at equilibrium position, velocity used to be what? Maximum, if you know. Yes, क्योंकि velocity का formula आपने क्या पढ़ा है? Omega A root under 1 minus x square by a square. So in general case, when x is the equilibrium position, x will become 0, okay? And velocity will become omega a, which is the maximum value. So at this position, what is the case? At this position, it has certain velocity already. And when you are, it means it has momentum. So before dropping the mass at equilibrium position, I'm discussing first the first case. So initial momentum of this system is how much? M into V, where V is the speed of this mass, which will be equal to omega into A. Now, what will be the final momentum? Final momentum and initial has to be same. Why same? Because no external force is acting and both are getting stuck to each other. I mean, let's say this is a small mass M. Now these two are getting stuck to each other and then moving together. So final momentum you can write as what? M plus M into small u. Okay? And these two will be what? Equal. Now let's talk about these things. The amplitude of oscillation in the first case changes by a factor of this. Amplitude is going to change by a factor of this. How we will check that? See here, let's do this thing. So M into omega A will be equal to what? M plus M into how much? This U is now equal to what? So this U seems like there is a string and then there is mass of M plus M, and this is performing SHM, and at equilibrium position, it has a speed U. Okay? So for this system, for this new system, this speed U will be equal to omega dash into A dash. Omega dash into A dash. Okay? Done hai? So this is this. You write here omega dash into A dash. Now if you check it, M into omega A will be equal to M plus M. ओमेगा डैश को आप क्या लिखोगे? ओमेगा क्या होता है? ओमेगा होता है k by m. ये होता है ना? So initially omega is how much? This is equal to k by m root under, and now system has a mass of m plus m, so omega dash is k by m plus m root under a dash. ठीक है? We can solve it now. आप k को cancel कर डालो यहाँ से. This will become root under m into a, and this will become root under m plus m into a dash. So a dash, if you look like, it will become m by m plus m into a. This is going to be your new amplitude. This is going to be your new amplitude. So definitely amplitude will change in the first case, and it will get changed by a factor of this, A into this, right? So that is correct, I feel like. Whereas in the second case, it remains unchanged. Let's explore the second case. अगर आप second case को explore करो ना, then in second case, what you are doing is body is at rest. It is at rest, right? And then you are dropping a mass over here. ठीक है? How it is going to, is it going to affect the amplitude? चलो मुझे सोच के बताओ अब तुम लोग. Now you need to think on it. थिंक वाइजली. देखो एनर्जी के टर्म में सोचना स्टार्ट करो, क्योंकि यहाँ पे जब एक्सट्रीम पोजीशन पे है तो इसकी वेलोसिटी तो जीरो थी बिफोर ड्रॉपिंग द मास एम. आफ्टर ड्रॉपिंग इट we have placed it softly, so we have not supplied any velocity or anything, still it is zero. So momentum initial zero, final zero. Done है? Clear है? And if you talk in the terms of energy, at the point when you are dropping a small mass m on the capital mass M, what is the system's energy? Half Ka square. This is the system's energy, right? And will energy change after dropping mass small m on the surface of capital M? No, because we are not, adding any dissipative force. There is no momentum change that velocity will change, and hence energy equation is going to change. Nothing has happened, right? So if at this point, when you are dropping the mass m on the capital mass M, system energy is half Ka square before dropping the mass. After dropping the mass also, system's energy is half K square. And now let's imagine that this m plus m system is now coming at this equilibrium position. ठीक है, यहाँ पे ड्रॉप किया हमने, उसके बाद ये इधर चल के इधर आया. So at equilibrium position, now if you talk about energy, here only there will be kinetic energy. Half m omega square, omega dash square, a dash square, कुछ भी ले लो. But this has to be equal to half k square, right? So if half k square is not changing, then omega a will also not change. So in this case, uh, overall omega a together will not change. ठीक है, ऐसे भी देख लो टोटल एनर्जी कंजर्व्ड है. सो हाफ के स्क्वायर इज कांस्टेंट, राइट? सो एम्पलीट्यूड विल रिमेन ए because k is not going to change, a is going to change. If you talk about omega a is not changing. Here omega will change. If you see here, omega will change here. How? Yes, omega has to change because maximum kinetic energy की अगर आप बात करोगे ना, you will write like half m plus m omega square a square. ठीक है, a is not changing, mass is changing. So omega has to change in order to keep things balanced. क्योंकि total energy तो same रखना है, half k square. So a is not changing, mass has changed. So one more thing should change, and that is omega here. क्योंकि omega का value क्या लिखोगे? K by m plus m. So it's going to change. Done it? So overall omega a will change where a is not changing, right? So if you अगर तुम सही से इस क्वेश्चन को एनालाइज करो ना, इस वाले टॉपिक को, देन आई विल टेल यू वन थिंग कि व्हेन यू आर ड्रॉपिंग मास ऑन द एक्सट्रीम पोजीशन where this system was having no velocity, after dropping the mass or before dropping the mass, total energy of the system will remain conserved, half k square. So amplitude will remain constant क्योंकि एनर्जी रहा है कंजर्व्ड. ठीक है, एंड किसी भी पॉइंट पे दिस टोटल एनर्जी विल बी इक्वल टू द मैक्सिमम काइनेटिक एनर्जी. एंड मैक्सिमम काइनेटिक एनर्जी आप क्या लिखोगे? हाफ m, दैट इज m प्लस m ओमेगा स्क्वायर a स्क्वायर. तो ओमेगा डैश का स्क्वायर a का स्क्वायर. हियर ओमेगा डैश हैज चेंज्ड क्योंकि नाउ दिस इज हैविंग मास m प्लस m, so you will write k by m plus m. अब आप सारे ऑप्शंस को देख लो एंड ट्राई रीडिंग इट. ओके, first क्या है? Where is it? In the second case amplitude is not going to change. Yes, so one is true. The final time period of oscillation in both the cases is same. Yes, it is same. Why? Because in both the cases omega will be same. ओमेगा दोनों ही केस में क्या होने वाला है? k by m plus m. So time period is what? 2 pi by omega. So time period will be same. The total energy decreases in both the cases. No. In second case, energy is remaining conserved. In first case, yes, it's changing. So yeah, C uh, wrong है, because in second case it's not changing. D, the instantaneous speed at x node of the combined masses decreases in both cases. अब देखो दोनों ही केस में आप वेलोसिटी का ये लगा लो, क्या हुआ है, u तो डेफिनेटली डिक्रीज किया है ना, बिकॉज u you are writing as what, mv by m plus m, so definitely m plus m is greater than m, so this is going to be less than v. So in first case, u is smaller than v, that is speed has decreased at equilibrium position. If you talk about the second case, then in second case, I said you कि जब ये equilibrium position पे वापस से आएगा, it will have certain speed here. And I told you that speed is equal to omega dash a. And omega dash is what? Omega dash क्या हुआ है तुम्हारा? ये तुम्हारा decrease हुआ है. क्योंकि initially it was root under k by m, now it is k by m plus m. So it has decreased. So overall speed has decreased in both the cases. So option D is what? Correct. So option A and D and B, these three are correct. ठीक है? चलो, now let's do this question. किसी को डाउट हो, you can ask me, ठीक है? तो collision plus SHM के भी काफी क्वेश्चन देखते हैं. And in these cases, collision case will be more simpler. I mean, not complex collision, just simple collision happening. Yes. Should we discuss it now? चलो देखते हैं. So, what is the question given? There is a particle of mass m that is connected to a spring, and that is lying on a frictionless horizontal plane. The other end of the spring is fixed, as you can see. The particle starts moving horizontally from its equilibrium position with speed u naught. Let's say it started moving like this. ठीक है? Because it is colliding with the wall, we will take it is moving towards left, and there is one wall here. Let's say, ठीक है? So when the speed of particle is 0.5 u naught, it collides elastically with a rigid wall. So when it will reach here, it will collide with the wall. Okay? And at this point of time, it has a speed of 0.5 v naught, and it is colliding elastically. What do you mean by this elastic collision? It has a simple meaning that this block after colliding will get velocity in this direction equal to 0.5 u naught, right? Now it is connected to spring like this, and it is this. ठीक है, कुछ ऐसा होगा. When the speed of particle is this, it collides this. After this collision, what you can say? The speed of particle when it returns to its equilibrium position is u naught. Is it right or wrong? What do you think? What do you think? कोई भी बताओ. Wrong? क्यों ऐसा लगता है तुम्हें? क्यों wrong होगा बताओ? If you look here carefully, तुम ध्यान से सोचो कि तुम्हारे पास एक स्प्रिंग है, ठीक है? ये वॉल है और ये स्प्रिंग है. ऐसे you are giving it velocity u naught in this direction. It will go up to extreme position. Let's say there is no wall, so it will go up to extreme position where velocity will become zero, and then because of this force of a spring, because of the force of a stretched spring, it will start moving in this direction, this block, and gradually it will start gaining the velocity, and then there will be a point or position where its velocity will be 0.5 u naught in this direction. It will have, right? So here, if you look at the wall, and in this case, the explanation that I'm giving, when it will again come back to the equilibrium position, it will again have velocity u naught, but in the opposite direction. Okay? So speed will be same, right? Now in this case, what happened? There was a wall. In this case, the problem is this block is not able to reach to its extreme position. Rather, in at a point in the middle or somewhere, there is a wall which is giving it impulse, which is giving it or applying it force for a very small amount of time, and hence I'm calling impulse, which is simply reversing its direction. ठीक है, यहाँ पे सिंपल तो यही हुआ ना, एनर्जी में चेंज तो नहीं हुआ. देखो, जस्ट बिफोर द कोलिजन एनर्जी ऑफ बॉल वाज हाउ मच? हाफ m 0.5 u naught का स्क्वायर, राइट? एंड व्हाट वाज द पोटेंशियल एनर्जी? हाफ k x स्क्वायर, और वट एवर वॉज द एक्सटेंशन, एक्स नॉट ले लो. ठीक है. आफ्टर कोलिजन व्हाट इज द काइनेटिक एनर्जी? अगर आप लिखो तो हाफ m 0.5 u naught का स्क्वायर प्लस हाफ k x naught का स्क्वायर, right? So before collision energy, after collision energy, it's same. After all, this is elastic collision, right? It's same. So if here it has a speed 0.5 u naught, it is reverting back like this. When it will reach the equilibrium position, its speed has to be equal to u naught, right? Because nothing has changed. It just like this case. It's just like this case, the one I explained. Only the thing is कि किसी ने उसको बीच में बोल दिया लौट जाओ. ठीक है, विदाउट इम्पार्टिंग एनी चेंज टू इट, एनी इंटीग्रल चेंज, आई वुड से. डन है. So first looks correct. When it returns to equilibrium position, it's correct. Now the time at which the particle passes through the equilibrium position for the first time, it started from equilibrium, right? It started from here. It came up to here, up to the time when its velocity was how much? 0.5 u naught, and then it started reverting back. So what is the time it will take to come back to its equilibrium position again? कैसे निकालोगे बताओ? बताओ. What you will do? Tell me. Equation use कर लो. I mean, which equation you will be using? initially started from equilibrium position, right? Yes. So equilibrium position say whenever there is a spring mass system SHM, you can simply write A sine omega t. Okay? And this is this velocity you can write as A omega what? Cos omega t. So if you talk about this, then this is maximum speed, right? So V equal to U naught cos omega t, right? Now we can calculate the time when it will go from equilibrium position to the point of wall. ठीक है? Equilibrium position से to the point of wall जाने का मतलब its speed will become u naught by 2, right? So here you write u naught by 2 and this is u naught cos omega t. So this is how much you will be getting. Omega t will become here how much? Pi by 3, right? So omega t is pi by 3. Omega is how much? अगर मैं time period के term में लिखूं, omega 2 pi by omega. Omega is 2 pi by t. So 2 pi by t into t equal to pi by 3. So this is going to be how much? Pi uh, t equal to pi by sorry t by 6. T equal to t by 6. ऐसा दिख रहा है ना? So t by 6 टाइम में ये इधर जाएगा. Again, in t by 6 time, it will come back. So overall time will be how much? T by 3, right? And is it t by 3? कौन सा क्वेश्चन है? The time at which particle passes through equilibrium position for the first time. So this is how much? Time period कितना होगा? 2 pi root under m by k. So this is basically t by 2. This is t by 2, right? Our answer is how much? T by 3. So this cannot be correct. So this has to be wrong. The time at which maximum compression of the spring occurs. Maximum compression कब होगा बताओ? मैक्सिमम कंप्रेशन का मतलब वो जो तुम्हारा ये स्प्रिंग सिस्टम था यहाँ से स्टार्ट हुआ था, डन है, और यहाँ से स्टार्ट होकर वो यू नॉट तक गया, यू नॉट बाई 2 तक वेलोसिटी तक गया. कितने टाइम में? टी बाई 6 टाइम में. वापस आया कितने टाइम में? टी बाई 6 टाइम में. एंड देन इफ इट गोज हियर टू कॉम्प्रेस इट टू द मैक्सिमम, कितने टाइम में जाएगा? टोटल टाइम को अगर टी मान लो, then time that it will take to move from equilibrium to the extreme position will be equal to t by 4. So this is t by 4. Overall time अगर आप जोड़ो तो t by 3 plus t by 4 it should be. So it should be 7 t by 12. ठीक है? आंसर दिया है क्या? नहीं. This is not matching with that, right? So we have calculated everything right? चेक कर
2
लेना एक
times
बार.
t by 3 होना चाहिए ना.
हाँ, क्या क्या?
2 times होना चाहिए ना t by 3.
2 टाइम कैसे होगा? एक बार ऐसे गया, टी बाई 6 टाइम में गया है ना, फिर वापस आया टी बाई 6 टाइम में. टी बाई 6 ऐड करोगे तो क्या होगा? टी बाई 3. क्लियर है? एंड यहाँ से यहाँ जाने में तो टी बाई 4 लगेगा, क्योंकि अगर अगर तुम पूरे ये कंडीशन की बात करो तो यहाँ से अगर स्टार्ट करता है तो एक्सट्रीम पोजीशन जाने में टी बाई 4 लगता है, वापस यहाँ आने में टी बाई 4, अगेन कॉम्प्रेशन maximum t by 4, again here t by 4. So overall t. ठीक है? So this will be t by 4 definitely. T by 3 if it is, then answer should be this one. अगर हमने यहाँ कुछ करेक्ट नहीं, गलत नहीं किया है तो you need to check it. But यहाँ पे सिंपल है, क्वेश्चन ऐसे पुट करके you can calculate time at which particle passes through equilibrium position for the second time. अब देखो वो सेकेंड टाइम कब क्रॉस करेगा, तो आप ध्यान से देखो सेकेंड टाइम इक्विलिब्रियम को कब क्रॉस करेगा. फर्स्ट टाइम कब किया? पहले तो वो ऐसे गया, वापस आया, तो टी बाई 3 टाइम में क्रॉस किया फर्स्ट टाइम. आफ्टर दैट इट विल गो हियर, compress till the maximum t by 4 time, again it will come here in time t by 4. So extra t by 4 you will add here, and if you add this to t by 3 plus t by 4 t by 2 will give you how much? This is 5 t by 6. So in this time, it will second time cross the equilibrium position. सो अगर इसको पुट करो तो 5/6 2 pi√m/k. So this is equal to how much? 5/3 pi√m/k. So yes, this will be correct. These two are wrong. ठीक है. So this way you can solve the question. Clear है? I hope it is clear. If not, you can again go through it. ये question 2024 का था. I included it. Should we do it or what? Again, question is not difficult. Try to make it more easier. This question is actually very easy. You just need to deal with the concept जो अभी तक हमने किया, momentum thing and all. Just you have to take care of that thing. You will be able to understand the question. And first you need to read the question very carefully. You will be able to do it. ठीक है? So rest question I will be sharing as your practice questions. So there are so many I have added here actually. So you will be doing it. Any doubt, if you're having any particular thing you want me to explain, then you can discuss. Let me know.
मैम एक बार लास्ट वाला क्वेश्चन एक बार फिर से री एक्सप्लेन कर दीजिए.
ओके, और टाइम में कंफ्यूजन है क्या?
यस मैम, एक्चुअली वेलोसिटी वगैरह का भी थोड़ा कंफ्यूजन था, लाइक कि
ओके
वो इक्विलिब्रियम से मैम वो v नॉट जो है वो जीरो नहीं हुआ, फिर भी u नॉट पे ही कैसे जा रहा है, थोड़ा कंफ्यूजन था.
ओके, वेलोसिटी से अगर तुम डील करो ना इस क्वेश्चन में, आई हैव नॉट टेकन एक्स्ट्रा स्पेस, सॉरी फॉर दैट.
मैम
बट
एक्चुअली इसी में ही एक्सप्लेन कर दो विद द डायग्राम गिवन, लाइक जो आपने पहले से बनाए हैं एक बार ही
अच्छा,
एक्सप्लेन, लाइक.
डन है डन है. सो एक्चुअली क्वेश्चन क्या था ना, तुम्हारा जो मास m है इनिशियली इक्विलिब्रियम पोजीशन पे. इक्विलिब्रियम का मतलब जानते हो, वहां पे स्पीड मैक्सिमम होगी. तो इट हैज मैक्सिमम स्पीड u नॉट एंड देन इट स्टार्ट मूविंग टुवर्ड्स द लेफ्ट. लेफ्ट में क्या था? वॉल था. वॉल से इलास्टिक कोलिजन होता है. सो इट विल सिंपली रिवर्स इस डायरेक्शन विद द सेम स्पीड. डन है. सो जब ये इस डायरेक्शन में जा रहा है, इसकी स्पीड है 0.5 यू नॉट. डन है. क्लियर है. तो मैं ये कहना चाह रही थी कि just imagine that there is no wall. In that case also, at this particular position will be this, and here speed will be 0.5 u naught itself. ठीक है. So because of wall and without wall, at the same position you are getting the same velocity, magnitude wise, direction wise. So nothing is going to change regarding what will be the velocity of body at its equilibrium position. It will be same as it was initially, u naught. क्योंकि देखो फर्स्ट ऑप्शन में हमें ये दिया है कि स्पीड क्या होगा जब वो इक्विलिब्रियम पे पहुंचता है. तो इक्विलिब्रियम पे पहुंचने के बाद एनर्जी में कुछ चेंजेस तभी आएंगे इफ समथिंग डिसिपेटिव एक्टिविटीज हैज हैपेंड. बट नथिंग
यस
हैपेंड एक्चुअली. वॉल ने सिंपली इसको इम्पल्स दिया, बिकॉज ऑफ दैट इट्स डायरेक्शन गॉट रिवर्स. energy term is energy is same, right? Velocity is 0.5 u naught. So again it will come back here and its velocity will be same.
यस मैम, मैम आ गया समझ
Okay,
जिसमें कंफ्यूजन थी.
चलो ठीक है, ये बढ़िया है.
यस मैम.
टाइम निकालने का इक्वेशन से कर सकते हो, ठीक है, क्योंकि
यस
हमें
मैम, ये वाला
वेलोसिटी
तो हो गया
डिफरेंट
था.
डिफरेंट
यस मैम.
हाँ पोजीशन पे दिया हुआ है. वी कैन डील विद दैट. ठीक है. किसी और को कोई डाउट है?
थैंक यू मैम.
थैंक यू सो मच. नो डाउट, देन वी आर गुड टू गो. ठीक है. चलो, थैंक यू सो मच एवरीवन. थैंक यू एंड बाय बाय.